We will consider the example of predicting price and construction time, which we examined in the last lesson. To do this, I've created a training table with some project data. Here we have information about 9 previous projects. Based on this data, we will predict the duration and cost of building Project X. For Project X, we know it has 23 apartments, 3 floors, 25 meters of width, 14 meters of length, and a total area of 1,200 square meters. First, save the table in CSV format. This format stores tabular data separated by commas and is suitable for importing and exporting large datasets. We will work with this data in Jupyter Notebook. While Jupyter can be set up on your computer using Anaconda, the Kaggle platform is more convenient. Kaggle has pre-installed libraries required for machine learning, so we don't need to install them manually. Go to the Kaggle website, register if needed, and sign in. On the left panel, select the Data tab. Then click Add New Dataset and upload the CSV file from your computer. Give the dataset a name and save it on the Kaggle platform. Once saved, you can view the file and its summary. To work with the data, create a new Jupyter Notebook. As you can see, in the first code block of the notebook, the Pandas library and the NumPy libraries are already imported. Then create a data frame by loading the CSV file. The file path is accessible in the Data section on the right panel. Using the head function, display the first 10 rows of the table. Exclude the last row, which corresponds to Project X and will be used for prediction. Use the drop function to remove it. The describe function provides a basic statistical overview of the data. This includes counts, means, standard deviations, and more. It's a quick way to gain insights into your dataset. We notice columns for time and cost are not recognized as numeric values but as strings. To fix this, use the PD to numeric function to convert them into numeric data types, specifically float 64. After conversion, we can visualize the data as a colored encoded matrix using a heat map. Use the heatmap function to display correlations between variables. Add the correlation coefficient as labels using the X label and Y label arguments. The correlation of a variable with itself is always 1, which explains why the diagonal values are 1. A high correlation coefficient, close to 1, indicates a strong positive relationship between variables. For example, the total area of the building has a strong correlation with other parameters. We also observe a strong correlation between the number of floors and the number of apartments. These insights highlight which characteristics are most important for predicting price. Now we can begin training a regression model. A dataset for machine learning is typically divided into at least 2 subsets. Training set, used to train the model and optimize its parameters. Validation set, used to adjust hyperparameters, which are high-level settings not learned from the data. Typically, 80% of the data is allocated to the training set and 20% to the validation set. However, the exact split depends on the dataset size. Next, we will split the data into X-array, features for training, or as you can say, building parameters, and the Y-array, target variable, or as you can say, the price. Exclude columns with text data, such as the project name, as they cannot be processed by linear regression models. Used train test split to divide the data into training and validation sets. So the idea is to train the model on the training set and evaluate its performance using the validation set. Now that we have split our dataset into training and validation sets, we are ready to fine-tune our models. In the next lesson, we'll predict the cost and construction time from project X using the model and the specified parameters.